Okay, so this is acids and bases notes 1. We're going to talk about the characteristics of acids compared to bases. So remember, an acid is going to start with a hydrogen, and bases are going to end in a hydroxide. Okay? So properties of each. How do they taste? Let's think of an orange for an acid and think of soap for a base. So let's think of something citrus for an acid, and we can think of soap for a base. So how does a orange taste? It tastes sour. Versus soap, it's going to taste bitter. If I go too fast, feel free to watch this at home, or feel free to pause the video at your leisure. Okay, so citrus, we're not going to say that it's going to feel sticky because that's actually the sugar. So we're going to say it's non-applicable, but the base is going to feel slippery. A reaction with an active metal like zinc. Okay, so if we put zinc, like we did when we learned single replacement reactions, plus hydrochloric acid, we know that we got zinc chloride plus hydrogen gas. Okay, so this always forms hydrogen gas. And remember, hydrogen is a Brinkelhoff. Let's balance this so we'll have a 2 here. It's non-applicable for a base because it doesn't react with it'll just create a zinc hydroxide, but it doesn't form that hydrogen gas. Acids, they don't really react with fats and oils, whereas a base does. Conducting electricity or forming electrolytes. Remember, we just got through learning about that. Strong electrolytes. These will ionize or dissociate into their ions at nearly 100%. And both acids and base do that. Corrosive. Well, remember, we learned that corrosive means eat at or eats away at. Eats away at. And both of these guys are corrosive. Now, a pH meter. What is the pH? So 0 to less than 7 is an acid, and then greater than 7 to less than, or I'm sorry, greater than 7 to 14 is going to be a pH. A pH is a man-made scale, okay? And you can, you can say, what does it mean? What does pH mean? Some people say percent hydrogen. There's different names for what is pH. So there's some things that you need to know about it. Again, this is a man-made scale that's kind of, what is the word I'm looking at? Novel, if you will. You must memorize it and all the information that I am about to give you on it. So please make sure that you do so. Okay, so we're going to draw a line. Okay. We're going to cut that line in the middle, and we're going to call that 7. Here we're going to write 0. Here we're going to write 14. Okay? 0, 1, 2, and 3. So 1, 2, and 3. These are going to be our strong acids. And remember, an acid is from 0 to less than 7. Our bases are going to be greater than 7 to 14. So our strong bases will be 13, 12, 11. These will be our strong bases. And remember, to be strong, it must ionize at nearly 100%. So here, let's highlight this, acid and a base. So we'll have acid to nearly 7. Actually, let's do a base in pink. And then we'll do base all the way here. Okay. So acids versus bases. So these 4, 5, and 6, these are called our weak acids. 8, 9, and 10, you guessed it, are our weak bases. Okay, so let's talk about hydrogen versus hydroxide. So hydrogen, if we add a hydrogen, which is what acids start with, plus water, we're going to get a hydronium ion. This is called a hydronium ion. And it has a +1 charge. So acids have a greater hydronium concentration than hydroxide concentration. So OH minus is hydroxide. And of course, the hydronium concentration will be less than the hydroxide concentration on the bases. Okay. So let's fill this in. Acids, what did we just say? That acids will have a greater hydronium concentration. So there's more H3O plus ones. Bases will have less hydronium, so therefore there'll be more hydroxides. And then neutral, we didn't talk about this. Neutral is 7. Neutral. And this is where your hydronium will equal your hydroxide. So here this will be equal. These will be equal. Okay, so I want you to stop for a second, and I want you to pause this and practice these on your own. Yes, you can cheat and continue the video, or you can actually practice this and try to learn it. So practice, identify the following as a strong acid, a strong base, a weak acid, or a weak base. Also identify if each of the following has more hydronium or hydroxide or an equal amount. Now, again, it's your choice to pause the video and practice or continue. So a pH of 8 will be a weak base, a WB, and it will have a greater hydroxide concentration. 6.5 will be a weak acid, and it will have more hydronium ions. pH of 7 will be neutral, and it will have equal hydronium to hydroxide concentrations. A pH of 3 will be a strong acid, and of course it will have a greater hydronium concentration. A pH of 11.5 will have a pH of 11.5 will be a strong base, and it will have a greater hydroxide concentration. A pH of 13 will be a strong base, and it will have a greater hydroxide concentration. Okay? Flipping over to the back indicators, I'll do on another video.